Welcome guys to module number 2. Today we're going to be talking about average rate of change. To motivate this concept, let's take a look at this graph. Let's assume that this blue graph corresponds to the number of cars that a company produces with respect to time, with respect to number of hours. So here you have on the x-axis you have time, and on the y-axis you have number of cars. Oh, I think I wrote a little outside of the margin. Well, sorry about that. So let's take a look. At the 0 hour, there's nothing produced. But then when you go to the first hour, you have 10 cars produced. Then in the second hour, you have 25 cars produced. In the third hour, you have 28. And in the fourth, you have 38. So if we were to look at the time between, say, hour 1 and 2, in that span, or in that period of time between hour 1 and 2, the company produced 15 cars, because you would be doing 25 minus 10, and the time that happened would be, or this happened would be between hours 2 and 1, so in 1 hour. So that's what we're going to call the average rate of change. So an average rate of change in between 1 and 2 would be the number of cars that we produce in hour 2, which is 25, minus the number of cars that we produce in 10. This gives us the total number of cars produced in that span of time, divided by, well, 2 minus 1. So it gives us how many cars in average were produced in this span of time. And that gives us that in average 15, the average rate of change was 15 cars per hour. So for example, if we were to repeat that for times between 1 and 3, for example, well, then you would say that they produced 28 cars by the third hour minus the 10 they had produced by the first. That gives you the total increase in number of cars, gives you this distance right here, in the span of time in between hours 1 and 3. So for example, this would be 28 minus 10. And then the time that passed would be, well, 3 minus 1. So it would be in 2 hours. When you divide this 28 minus 10 by 3 minus 1, that gives you the average number of cars that were produced between hours 1 and 3 per hour. So this would be what, 18 divided by 2, so about 9 cars per hour. So this gives you an average or an estimation of how fast the production is happening in certain intervals of time. So with this in mind, we can give now a definition for the average rate of change. So to do this, let's look at this graph. Suppose that you have a function. Say this function is y equals f of x. And then if you have 2 points, say x1, y1, and x2, y2 that live on the graph, or that are located on the graph, if you draw the line that connects those 2 points right here, that line is going to be called the secant line to the graph of the function f between the points x1, y1 and x2, y2. Now, what would this, or how could we write the slope of this line? Well, the slope of this line, let's call it slope m, and let's write sec for secant line, and then what it would be y2 minus y1 divided by x2 minus x1. That's just the definition of the slope that you learn in pre-calculus. Now, since y1 and y2 happen to be on, or the points x1, y1 and x2, y2 live on the graph, then y2 would just be equal to f of x2, and y1 would be f of x1. and then this secant, or the slope of the secant line rather, can be written in terms of the function and only the x coordinates. So that slope will be called the average rate of change. So right here I could have written it as f of x2 minus f of x1 over x2 minus x1. And that gives me the average rate of change for the function f with respect to x1, or from going from x1 to x2. Now, there's a special case for this average rate of change, which is whenever you have the following picture, where x1 is equal to x and x2 is equal to x plus h. Then your average rate of change here would become the following. So in between x and x plus h is going to be f of x plus h minus f of x, that's the rise in the y coordinate right here, divided by the run in the x coordinate, which would be x plus h minus x. So x plus h minus x, which gives you just h. So you divide the rise by the run, and you get this expression that is also called or known as the difference quotient. And I am sure you have calculated many of those quotient, many of those in pre-calculus or college algebra or whatever course you took before this. So this is, I already wrote what this is, and this is known as the difference quotient. Let's calculate one of those. So suppose that f of x equals 3x squared. So what would the difference quotient be? Well, the difference quotient would be the average rate of change between, that's a funky R right there. Oh well, between x and x plus h. That's the difference quotient, and that is just f of x plus h minus f of x all over h. And in this particular case, what is f of x plus h? Well, it's just 3, and instead of x, I plug in x plus h in parentheses, always keep that in parentheses, and I can expand it, and that would become 3 times expanding the, or foiling out the square, you get x squared plus 2xh plus h squared. This term right here is usually forgotten. Please don't forget about it. So keep that in mind, okay? As just the double product, a lot of people will just square x and then square h and completely forget about the double product. Please don't forget about that. To convince yourself that that term appears, just FOIL x plus h times x plus h, and you will see that you'll get that term right there. In any case, now f of x will be just 3x squared. So whenever I do, oh, I forgot a c, the average rate of change between x and x plus h, I would get f of x plus h. Let me copy it. So I'm just substituting f of x plus h with this, and perhaps I should have distributed out. I will do that in the next step, just not to do several steps at once. Then minus f of x, which is 3x squared, all over h. Alright, then we distribute this here, so you get 3x squared minus 3x squared, that's going to go away, and then you get 6xh plus 3h squared all over h. So I can then factor h out of this, and I get 6x plus 3h all over h. Now, I should have made a note here that h is not equal to 0, and in that case, I can actually divide this or cancel this out and get 6x plus 3h. Just by dividing this out. Notice that I cannot just divide one term at a time. Sometimes people do that, and that's not right. That people would cancel the h here and write just 6x plus 3h squared. That would be incorrect because you're dividing the whole expression, so you need to divide term by term, or easier, factor it out and divide the h. In any case, this is our answer, and that is the difference quotient. We'll do one more before this video ends, and that will be calculating the difference quotient for this particular function. So to do that, you need to calculate f of x plus h, and that's going to be 1 over x plus h. And then the average rate of change then between x and x plus h, which is our difference quotient, is going to be f of x plus h minus f of x all over h. And that then becomes, let me write the 1 over h in front. Just instead of dividing by h, I'm going to multiply times its reciprocal, just to so it looks better. Then I would have f of x plus h minus f of x in this parenthesis, and f of x plus h is going to be 1 over x plus h minus f of x, which is 1 over x. So all I did, I substituted f of x plus h, f of x, and I obtained this, and instead of dividing by h, I multiplied times its reciprocal. Okay, so let's delete those arrows, and let's leave it like this. Alright, so now I have 1 over h that multiplies this expression right here. When you have the difference or the sum of two fractions, well, how do you sum fractions? Well, the only thing you can think of is do common denominator. So the common denominator here would be x times x plus h, and then in here you would have x plus h, sorry, x times x plus h divided by x plus h, which is going to be x, and then minus x times x plus h divided by x, which is x plus h. Or if you want, you just cross multiply them. And in that case, we get 1 over h times x minus x is going to be 0, minus h is going to be negative h. So just distributing the negative and subtracting or operating. And then x times x plus h. And now you have this negative h that is multiplying everything and an h that is dividing everything. So you just have a negative 1 coming out. You can put it outside. And that gives you your difference quotient. So that's it for this, or the beginning of this section. See you in the next video.